Hello friends, Reddy, HK, Associate Professor, Department of Electronics, Government Autonomous College, Gulbarga. Well friends, in today's video lecturing class, let us try to write and execute a microcontroller program to find 2's complement of a given hexadecimal number. Program to find 2's complement of a given hexadecimal number. Let 9AH be the hexadecimal number whose 2's complement has to be found. First we have to move 9A into the accumulator register, that is an 8-bit register. Then we have to complement this 9A. Source program to find 2's complement of a given number. Move, the instruction used to move 9A into accumulator is move A, hash 9AH, a 2-byte instruction. Then CPL, that is complement the contents of accumulator, which is a 1-byte instruction. As we know, 2's complement is obtained by adding 1 to the 1's complement. As 1's complement is already obtained, we have to add 1. The instruction used is INCA. Increment the contents of the accumulator, which is again a 1-byte instruction. Well friends, this completes the process of writing a source program to find 2's complement of a given number, but always the program is ended with an instruction L call, which is a 3-byte instruction. Total number of bytes required here, as we see, is 7 bytes of memory location is required to write this program into the RAM. The actual program fed into the processor is in the form of object program. The same thing, we shall put it into the object program format. In our microcontroller 8051 kit, the starting address is 8000. In this location, we shall write an opcode corresponding to the instruction move A, hash 9A. This is an 8-bit data. In the immediate location, because it is an immediate addressing mode, we have to give the data, that is 9A, or else any other data that you have taken to find 2's complement. This completes 2 bytes of instruction, first byte for the opcode and second byte for the data. Now let's come to the next instruction. It is an 1-byte instruction, therefore requires only an opcode. In 8002 location, an opcode for CPLA, that is complement the contents of accumulator. Since it is 1 byte, no data to be specified here. Next, INCA, a 1-byte instruction, only opcode is required. And in 8004, an opcode for L call hash 0003. That means it is a 3-byte instruction. First byte is for the opcode, second byte is for the lower byte, and the next byte is for the upper byte. And as you can see, it takes 7 bytes of memory location, 1, 2, 3, 4, 5, 6, 7, and the same is being obtained here. Now let's go for a result check. What result we are expecting when we find 2's complement of the given data 9A. So 9A H, that is an hexadecimal form, when converted into binary form, we get 1001 corresponding to 9 and 1010 corresponding to A. 1's complement of 9A. 1's complement of 9A, just by converting zeros into ones, we get 1's complement of 9A. So 1, put 0, 0, 1, 1, 0. Similarly here, 1, so put 0, 1, 0, 1. Now let's find 2's complement of 9A. To find 2's complement of 9A, we have to go for 1's complement plus 1. So already we have obtained 1's complement, add 1 to this. When you add 1, 1 plus 1 is 1, 0, 0 is sum, 1 is carry. So 1 plus 0, 0. Similarly, the next numbers are written because there is no change in the process of addition. So this is the result in the binary form. Now convert this into hexadecimal form. 0, 1, 1, 0 corresponds to 6. Sorry, I think 1 and 0, it should be 1 here, and this is again 6. Don't confuse. 1 plus 0, earlier I put 0 plus 1, 1 plus 0 is 1. Therefore, the result expected is 66H, that is in the hexadecimal form. Let us execute this using microcontroller kit. The moment kit is put on, it displays SDA 5.1. Before this, let us try to write the opcodes for these instructions. This is being obtained through the opcode sheet. As I told you earlier, the opcodes are written, you are looking at the opcode sheet. The first instruction is MOV A, hash 9A, and you can see here MOV A, hash data. It is a 2-byte instruction and the opcode is 74. Similarly, when we look into the opcode sheet, for CPLA, the opcode is F4. For INCA, the opcode is 04. And for LCALL, the opcode in the data sheet is 1, 2. So this is the object program which has to be actually fed into the processor for the process of execution. Now let's go to the microcontroller kit. The procedure to load the program and data into the controller is a reset button, substitute button, then 0 or R0 button, which is a common button, then the starting address of the RAM, in our case it is 8000, then go on pressing next to feed the next data. So reset, substitute memory or not, and the starting address of our program. The starting address of our program is 8000. In this memory location, we have to feed, press next. This field is displayed. 74 is the opcode for this instruction. Then just press next to increment the address 8001. Then feed the data 9A, whose complement has to be found. Next, F4, that is an opcode for CPLA. Next, an opcode for incrementing the contents of accumulator, that is 04. Next, the opcode for LCALL 1, 2. Next, 00. Next, 0, 3. that is in 800603. After this, once again we have to press next. Well friends, once again let's check the program that we have fed is right or wrong. Let us follow the procedure. Reset, substitute memory, R0, starting address of our program. Next, 74, 9A, F4, 04, 12, 00 and 03. Yes, the problem is being checked. Now, how to execute the program? First press reset button, then go button, starting address of the program, that is 800 in our case, and press execute button 2 times. Reset, go, 8000, execute. The controller has executed the program and it has came out. Now to check the result, as the result is in the accumulator, press exam register. It shows, it asks for which register you want to check. If you press A, the answer is 66. Now you can see the answer that you have computed earlier was 66. The same is the result which is displayed in the accumulator. That is, now accumulator consists of the 2's complement of a given number. Thank you friends for watching this video.